This is issue number 9 for, or 9. This is issue number 49 for the Kaiju Engine, where we're going to clean up some of the rendering code and make instanced rendering as the default. Currently, we're rendering or doing draw arrays and this sort of stuff directly in here, and we don't want to do that. The design for this is going to be that we are going to have our shader data inside of a structure that then we can pass along into our shader, just kind of pump it straight on through and work with that. And we're going to do that through a texture, at least for OpenGL. We're going to do that through a texture so that we have just access to that linear data as an instance. So we can start off by defining what our shader is going to look like. So I'm going to go to this basic vert and we'll add in a define here. Instance vec for count is 12. This is just the offset. So next we're going to set up a uniform sampler 2D instance sampler. And then lastly, we're going to pull our data from it. So the data we're going to expect is going to be a model matrix as our first block of data. And then we'll do a color so that we can multiply our base color by it. So I'm going to say model, or I say mat for model. And then int x offset is equal to gl instance id times that. Yep. So model 0 is equal to texel fetch instance sampler x offset 0 and 0. That's right. Then we're going to do model 1, model 2, model 3. It got all of those right. So next we're going to do vec for color is equal to offset 4 there, and then multiply color into here. And we can get rid of this model as we now have the model coming from our texture. So that's all the modifications that we're going to need to set up our instance sampler. So next we need a few more helper functions inside of GLES non.js. We're going to need the functions for our texture operations. So let's go up to our constants and let's add in some constants here. We're going to add in unsigned int. We're going to add in texture 2D. We're going to add in RGBA32F. We're going to add in RGBA. Texture wrap S. Texture wrap T. Texture min filter. Texture mag filter. Clamp to edge, nearest, and texture 0. Okay, so those are the constants we're going to add. Now we're going to need a gen texture. So we have gen buffers here. So let's create a func gen textures n int 32. That's pretty much what it's going to be, but this is going to be CGL gen textures. So we can go up here, void, add that in. I'm just going to trust what the AI does for now. It should get it after having all this context. And then I can come back and check it at the end. So gen textures, come back down here. Next, we have the bind vertex array and bind buffer. We're going to add in func bind texture. Is what I want. This is going to be CGL bind texture. So void CGL bind texture. Okay. Now, when we go to bind a texture, we're going to set a uniform 1i integer. Uniform 1i. This is just kind of saying the offset of the texture, what we're binding it to. So let's add that one in, void. Okay. one F, one I. Okay. Make sure I did that right. Yep. Okay. Just change that to one I. Next, we need to be able to set our texture data. So we're going to do func text image 2D. And all those arguments look like what's going on here. There's a lot of arguments to this guy. Let's jump up here, void. Call that directly. Next, we're going to do the text parameter I. Func text parameter I. There we go. Void. Okay. So now that we have all our texture stuff, the other helper we want is we have draw arrays. We're going to want to draw elements instanced because we're going to swap to doing instance. So func draw elements instanced. Put that in, make sure this is CGL. Void draw elements instanced. Then we have unbind. So we want to unbind texture. And that looks about right. And then we want a activate texture, which we don't have yet. And we're going to need to void activate texture. Okay, so that's all that we need for adding into our wrapper here for GL. Okay, so now I need, so I said I was going to do a block of data that we're going to be writing to the GPU for our, or to the shader GPU is the difference, for our instances. So we're going to go into the rendering and we're going to add in a new draw instance.go package rendering. I'm going to have a few things in here, just kind of like wrappers. So I'm going to have type draw instance. So this is just single instance. Data pointer unsafe pointer is going to be our. Oh, this isn't going to be a struct. This is going to be an interface. Then we're going to have a base that we're going to derive from here. So shader data base struct. Pretty much all of our shaders are going to have a model matrix. So we're just going to have that as a thing we can derive from, which means we can grab the data pointer, and it's not going to be from S, just because of how this thing gets hooked up. It may not be correct. So the easiest way is going to be s.model 0. We're going to start at the model. Essentially, everything that composes this shader database, or anything that implements this interface, should just be pure numbers that are getting pumped to the GPU. No pointers or anything like that. So next we're going to set up our grouping, and this is just makes it so that we can bind a shader, and everything under that shader is going to be inside of this group, everything that matches that model. We may refactor it a little bit later as we add a few more different kind of models and all of that in, make it a little more so that we bind one shader and then we go through all the groups that are related to that shader. But for now, we're just going to set up a type draw instance group struct, and this is going to have a shader, a mesh, a instances draw instance, a instance data, which is a byte array. I may refactor some of that part too. Instance size as an int, and data size as an int. It's just so that we can create things pretty. We can create our instances and know their size, and anytime we add an instance, we can expand that data. So we're gonna set up this, but we are not gonna have instance groups passed in. The shader and mesh is fine, but what we are gonna pass in is data size int, and we don't need this to return a pointer. So return group, and we're gonna say shader is equal to shader, mesh is equal to mesh. Instance, that's fine. Instance data, that's fine. Instance size, that's right, and data size is 0, and that's the current size that the data is. We're going to have a function for checking if it's empty, so func d draw instance group is empty. Oops, bool. Then we're going to have a func draw instance. Whoops, d draw instance group. Add instance, and let's see if this does it right. So we have instances, we're appending the instance, we are increasing the size by the size it is, and then of course this is not right. We're just going to append, we're just going to make a byte array of the instance size and have that go straight in to expand the array. So lastly, we need to be able to update the data. So d draw instance group update data, and this is just going to say the base is unsafe pointer to d instance data 0, so the beginning of the array. And then we're going to go through, we could say for I instance in range d dot instances. 2 is going to be equal to unsafe pointer of uint pointer of the base plus the I times the instance size. Okay. And then the from is going to be equal to the data pointer. And then we're going to copy unsafe.slice byte 2, 2, and then d.instance size, and then the same thing for from. Okay, so I'll just put this on separate line. And that should be what all we need for this. We're just essentially pumping instances in here, and then we're updating the array of memory, and we're just going to throw that array of memory straight to the GPU. Of course, maybe a refactor that I'm going to be doing is that when we add an instance, it can return an unsafe pointer or whatever to the address of the instance offset in the block of bytes here, and then we can just assign those bytes directly via their name types of the struct, and then we don't ever have to copy. We don't ever have to do this portion because we're writing directly to it. But we'll come back around to that once we get this working, because this is a little more straightforward at the moment. So we're going to go to our renderer, and we are going to change how draw works. We're going to pass in drawings is an array of draw instance group. And then we'll go to renderer.gl, and we're going to have to change what all we're doing here. So we want to bring over some of the stuff from main. We're going to do the GL clear at the top, and we're going to do for drawing. I'll just say draw and drawings. And then we're going to, this is actually going to happen in here. We want to check to make sure it's not empty. If draw.is empty, we can offload this to somewhere else, like don't even add it to the group if it's empty or something like that. Next, we want to update the drawing data, so draw.update data. And then let's go back to the main and see what we can grab here. So this GLUse program, that's definitely what we're going to be doing. But I'm going to pull this out to a variable, shader ID, and the shader is draw.shader. And this is going to be draw.shader. Okay, so now we have, let's see, this ready frame is fine. This draw is going. We're gonna fix that. We have bind arrays. So we are gonna bind the VAO, but I'm gonna turn this into a mesh ID. Mesh ID, and this would be draw.mesh, and then we don't need that. And we could say mesh ID there. Okay, next we're going to start doing the indexing stuff. So var instance text buff, and we're going to generate this texture every time right now, and we can essentially generate a large texture and resize it as part of the instance group. But for now, I'm just going to create it directly in line, get things going. Gen textures, one instance buff. We're going to bind the texture. This is just going to be texture 2D instance buff. Then we're going to do gl.text image 2D. And let's see what all we have here. So text 2D, 0, RGBA 32F. And then we're going to have, okay, this one needs to be int 32, the length of draw.instance data. Okay, because that's the width. So we also want to do divide by 4, divide by 4. RGBA and 4 bytes. So this height was just going to be 1. It's going to be a big old wide texture for now. 0 is correct. RGBA. Float is good. Unsafe pointer. Instance data 0. Okay. That looks good to me. So now we can do gl.text parameter I. Texture D, we're going to do, we're going to do the min and mag filter. I guess I could just put those in, but I also like to do the wrapping first. Wrap S is going to be clamp to edge, and wrap T is also going to be clamp to edge. Okay, so now we can do gl.unbind texture 2D, gl.activate texture 0, gl.bind texture. We're going to bind the instance buff, and then gl uniform 1i. And then we're going to get that instance data string from our, let me make sure I spelled it right, basic.vert. Instance data, wait a second. No, this should be instance sampler. It's not, there we go, instance sampler, and then 0. So now we can set up a gl.bind buffer, and we're going to do a gl.element array buffer, and we use the mesh ID EBO. Then we're going to do draw instance, yes, but it's going to be, let's make sure, triangles instance count, unsigned int 0, and then draw instances. So this 0 is wrong because this should just be similar to this. I'm actually just going to paste it in. Okay. And then we're going to do gl.unbind buffer, element array buffer, and gl.unbind vertex array. All right. So now our draw is updated. We need to come over here and actually do our drawing stuff. So first things first, we're going to create an arbitrary struct here to house our triangle data. So we'll create a type triangle shader data struct. And this is going to have rendering.shader database and color matrix.color, which is just a vector float array. I want the size of this thing as well, so let's do const size is equal to, yeah, you can type it in directly, but I'd rather do, and unsafe dot size of triangle shader data. Thank you. And now what I want to do is, rather than color green, we're going to do color white so that we can just multiply it and it'll be blended to whatever color we specify as part of its instance data. So I'm going to make my draw group is equal to rendering new draw instance group, triangle data size. This actually is going to be the mesh here. Let's just put it down here. Now we want to do T triangle shader data color. And I'm gonna do let's do red just so it's different. I think I was doing green before. And I'm gonna add the instance. And just for brevity, I'm gonna add in a rendering dot draw instance group. There we go. So it's an array of draw instance group going into that. At this point, we should be good to go, but if you remember, I just pumped the I pumped out a new texture every time here, so I probably should do gl.delete delete textures, and then I'm going to need that function. So let's go to the delete functions. Func delete textures. Oh yeah, it's an array. CGL delete textures. Pop that in there. Okay. So now we are creating and deleting a texture every time through here, but you know, it's just phase one of our refactor here. So let's compile it and see what happens. Okay, Seago. So we got an issue here. Let's just go straight to that. So first here can't be that. I think it's going in as a void pointer or whatever. So let's just have AI generate the unsafe pointer, uint pointer thing, and then just let it go from there. Okay, we got a nice, beautiful blue screen and nothing else on it. So we changed something, didn't we? Just gonna have to figure out what is missing here. Okay, this isn't the problem, but I did find that this needs to be glint. This was because it generated as the 1F before, and it put in the wrong cast here. So this will need to be glint, and this needs to be I. Could be the issue. I'll run it and find out, but I don't know if it would be the only one. Yeah, that's not our primary issue, but glad that I caught that. Also looking over here, this isn't a problem, but I do want this to be consistent here. Yeah, okay. Okay, one thing, I didn't set the matrix of this triangle. So if I did t dot, or the model I mean, is equal to matrix dot mat for identity. So if we don't have a model matrix, it is not going to show up. So there's our red triangle. Awesome. And now what I want to try to do is, let's see if we can make two triangles. So let's do, we're going to add in this. Here, let's just do this for readability and copy and pasteability. There's one triangle, two triangles, and we're going to make the second one blue. And we are going to move this one to the left, so t.model.translate. We're going to move it just to the left, thank you, by 0.25. And then I'm going to move this one to the right by 0.25. And let's see if we get what we expect out of this. Nope, we only get the 1. I guess I can move it over to 0.5. Will that be the closer to the edge? Cool. And so now we have our two instances. Let's make sure we're drawing both instances. We're pulling both instance datas in. let's see, renderer GL. I'm going to come in here, make sure that we're hitting these guys twice. We're hitting that one, continue, continue. So it looks like we're only drawing one. So drawings, there's only one. I didn't add the second one apparently. Draw group, add instance. Interesting. So, am I hitting this continue? Is that what's going on? We're going to add an instance. Let's step into it. This is our drawing group here. It's got no instances. Oh, length of one. It's got the instance we just added. Okay, continue. Step into this. We got our instances set. Okay, we have that one. Let's go to the next line. Instances. Now we've got the two in there. Okay, so our draw group. Instances 0 and 1. Oh, we didn't get rid of this guy. Let me get rid of that real quick. That's not going to explain why we're missing the other. So drawings is just going to be the one draw. Oh yeah, that's right. There's only one draw instance group. Duh. So we have the one draw instance group. It's got the mesh we're interested in because they share the mesh. It's got those two instances. And our instance data is here of a cap of 160, which is correct because we have two 80s in there. You see the instance size, 80. So let's step in here and let's check out. We grab our base. So our to address, it's going to be this guy. Oh, come on, let me just, jeez. Oh my gosh, I'm going to strangle. I'm going to strangle Visual Studio Code. Can I just right click and copy the address? No, it won't let me. Ha, take that. So I'm just going to copy that address and I will write that down. I'm going to drop it in here. And this is going to be from instance data pointer, which is going to be some number 143C0. And then we go through our second instance in our 2. Copy that guy, paste it in here. A and F, okay. Seems about right. From here, 144B0. Okay. So now we can check out our instance data. So the first 80 is going to be the initial data. The second 80, I guess we can just look at the color down here at the end. For the most part, that looks right. Let's see the color up here. Interesting. Well, I guess at this point we can just see what we are getting in the build. I'm gonna have to build this and run it through render doc to see what kind of data is coming in there. Okay, the easiest way was just to debug in Visual Studio Code and then launch the debugged version in here, so I didn't have to actually build it. So here's our instance draw, and if we go over to our mesh viewer, we have two instances, 0 and 1. You can see that the positions are all 0 here, though. The frag color is all 0 here, so everything's zeroed out. So it looks like the data that we're pulling is, well, Well, it's missing. So we might change this to use the method that I was hoping to use, where we return a block, an arbitrary pointer, and just unsafely assume it as that data. I'm not sure. Let me think about it real quick. I kind of want to do that as its own thing and just get this working for now. So another thing is it may not be copying that data to the texture. I just thought about it. I haven't checked it yet. So here we're doing instance data to 0, and the length is the draw instance data. And this is the width and the height. Border format. The height is 1 pixel. The width is, let's see, what is this going to be? Okay, so this should be right. We're getting 10 pixels. So the 160 bytes divided by 4 divided by 4, the width of 10 pixels. So that it is an RGBA. So there's 4 floats in there for each of those components. So we can actually look at the texture that we get. We get as an input here. And we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got all 10 pixels here. And these, the red, green, blue. So it looks like there is correct data in here to work with. So this is GL, so I don't think I can debug the shader like I can do with the Spear V and Vulkan. So I'm just gonna have to think through this one. Oh, of course. 12 was not what I needed. This is the how many vec4s I have in here. I grabbed this 12 when I was looking at the shader code for my other engine. But what we have here is we have 1, 2, 3, 4, 5 5 instances. So I'm actually going to take that define and put it right above here so we don't make that mistake in other shaders. Okay, that's probably what we're missing. There we go. We've got our 2 triangles, and I hate tangents, so I don't like when they're like barely touching. I don't know what it is. I like to make sure. There we go. There's a small gap there. Tangents are cool in mathematics, but they're not visually pleasing. So there we go. So we have our 2 triangles here. And just to play around with some stuff here, we're going to take that blue triangle. In fact, we're going to undo these brackets here, that blue triangle. And let's see what happens if we do a dot. Actually, yeah, I was going to rotate. On the z-axis, this probably is going to, let's make it spin 360 degrees delta time. 360 degrees by in 1 second, I think is what that's gonna equate to. Might be a little fast and jarring. Whoop, we've lost contact. Let's see what it's doing. Rotate. Oh, yeah, that's gonna be and I have to have a small number. Yep, something's goofing with our rotation. Oh, we translated it and then we rotated it. Let's just take this, paste that, rotate, then translate. And let's see what we got here. Bruh. All right, well, I was messing around with it. I didn't really get a good answer, so this is a problem for future Brent to work out. I don't really want to dive into the matrix math and all that stuff to play around with it. For all I know, it could just be a shader thing I'm doing weird in the shader. So yeah, at least this is working um, as I was hoping. Straightforward instance drawing, that is, with instance data. So in a future one, I'll probably also figure out how I can use that block of data and write directly to it as I set the values of a structure rather than copying it in every time before I draw. So I think that is just about it for this one. We have instance drawing now working, and like I said, another thing that we're going to want to deal with is how we are drawing. And here we are, first of all, we're creating a texture every time through. We don't want to create a texture every single time. We essentially just want to generate that texture as we add elements. And I mean, we could just copy straight copy this whole block or cut this block into our draw instance actually whenever we add an instance the draw instance group update texture, just drop that in there, and then we can create a GL handle for the texture. Now the only problem with this is obviously we're going to have to do something separate for Vulkan. So having this directly in here is because we're gonna be using uniform buffers for instance data in Vulkan. We're not gonna be using a texture. We're just using it for GL for backwards compatibility and all that sort of stuff. Simplicity of the GL code. So that I'll also defer to future Brent for now. I'll just call it GL texture or instance texture. It's fine. We're going to change this instant text buff. We're going to get rid of that. We're going to say d dot instance texture, wherever that is. Draw instance data. So this will be d dot instance data. Oh, this is going to be creating the texture data and binding it. Yeah, I'm going to leave it for now. So you bind the texture, unbind it. Well, yeah, I do kind of want to handle this um, in a different way, especially with Vulkan. So let's not mess up the code just for a small performance gain of something that we're not even going to um, fully keep this way. So let's just put this back. There we go. Deal with that. Clean up a little bit later and how we do it with GL. Cool. I think that's it for now then. Yep, more cleanup to come.